Hello and welcome to my science tutorials. In today's video, we want to look at how to calculate the equation of a perpendicular bisector of a line. Alright, so let's consider this diagram that we have. We have a straight line which is in gold or yellow over here with the points A and B. They all have their respective coordinates. So point A has the coordinate x1 and y1. Point B has the coordinates x2 and y2. Now, if we are to find the line that is perpendicularly bisecting this line, which is the one in green over here, which is the perpendicular bisector, that means the line that is cutting line AB exactly at the middle, forming an angle of 90 degrees. If we are to calculate the equation of that line, let's look at how we do that. Now, to find the equation of any line, we use the formula y minus y1 equals m into bracket x minus x1. This means that we need to know at least a point on that line, and also we need the gradient of the line, the gradient or the slope of the line. But now if we look at the diagram over here, all the information that we have is the point A and B with their coordinates. So how do we use only these 2 points to find the equation of a line that is perpendicular to the point AB? Now, in order for us to do this, we need to at least find a point on the green line over here, as we can see over here. The only way we can do that, since the distance between the middle where the green line cuts the yellow line over here is C, and then we can see these two lines over there, it means the distance is the same, which means that the perpendicular bisector is dividing the line exactly at the middle. So if we find the midpoint between A and B, that will give us a point in the middle here, which is also a point on the green line over here. So the first thing we do is to find the midpoint of the line AB. So to find the midpoint, we know midpoint is equal to x1 plus x2 on 2, comma y1 plus y2 on 2. So this will give us our midpoint. Now after calculating the midpoint, the next thing we need to do is to find the gradient of the line AB. Now if we find the gradient of that line AB, that becomes m1 as our gradient. We know that the line AB and the green line over here are perpendicular to each other. Because they are perpendicular, if we multiply the gradient of the line AB, which we are saying is m1, and the gradient of the green line, which I'm representing with m2, if I multiply those two gradients, I should get -1. Using this expression, after calculating my gradient m1 for the line AB, I can substitute that into this information and get the gradient m2 for the green line. Now, after getting the gradient m2 with the midpoint of the line AB, which is also a point on the green line over here, I can now substitute these two informations into this expression to get my equation of the perpendicular bisector of the line AB. Now let's have a look at an example so that you understand and appreciate how to use all this that I've talked about. So we are to find the equation of the perpendicular bisector of the line joining the points P, -4, 5 to Q, 2 and 3. Alright, so let's go ahead and write down our solution. Now for the purpose of this tutorial, I will be drawing our axis so that we can actually appreciate what is going on over here. Right, so let me draw my axis. I have over here my horizontal axis and then my vertical axis, which will be somewhere here. Alright, so let me label my axis. I have here 1, 2, 3, 4. These are not drawn to scale. This is my x-axis. This is my y-axis. So I have over here, I have -1, -2, -3, if I extend this a little, -4, I have over here 1, 2, 3, 4, 5, 6, over here -1, -2, -3, etc. Alright, so I have the points P with coordinate -4, 5, and Q +2 and 3. So let me go ahead and plot that on my graph. So my P, the point P is -4, that is the X, so -4, and then the Y is +5, so it's going to meet somewhere around here. This will be my first point, and then my second point is 2, 3, so my X coordinate is 2, and then my Y coordinate is 3, so that is going to meet somewhere here. So I can now go ahead and join these 2 points. Okay, right, so don't mind my imperfect line. So this is my point -4, 5, and then my second point Q, which is 2 and 3. Alright, so if this is our line, then it means our perpendicular bisector will be somewhere over here. So let me just draw some line to represent our perpendicular bisector. So let's say something like this, forming an angle of 90 degrees over here. So this, let's say this is our perpendicular bisector of the points P and Q. Alright, now in order to calculate the equation of this perpendicular bisector, we use y minus y1 equals m into bracket x minus x1. Now, like I said, the first thing we need to do is to find the midpoint over here where this golden line or perpendicular bisector divides this line PQ into 2 equal halves. So that is the first thing we need to find. To find that, we use the midpoint formula, which is equal to s1 plus s2 on 2, comma y1 plus y2 on 2. So our midpoint is equal to, our x1 is -4 plus our s2 is +2 on 2, then our y1 is 5 plus our y2, which is 3 over here, on 2. So this will be equal to, I have over here -4 plus 2 will give me -2 on 2, comma 3 plus 5 will give me 8. This is also on 2. So my midpoint value is now equal to -1 and 4. So the midpoint, or which is the point over here, is the midpoint over here is -1 and 4. Alright, so now that we have the midpoint, let's go ahead and calculate the gradient of the line PQ and use that to find the gradient of the perpendicular bisector. So the gradient M of the line PQ, let me use a different color for that. So the gradient of the line PQ will be equal to y2 minus y1 on s2 minus x1, and that will be equal to, this become my x1 y1, this is my s2 y2. So my y2 is 3 minus my y1, which is 5, on my s2, which is 2, minus my s1, which is -4. So this will be equal to 3 minus 5 will give me -2. 2 minus -4 will give me a +6. So this is equal to -1 on 3. Right, now we know that if we multiply the gradient M of the line that is in green with the gradient of the perpendicular bisector, which is in gold over here, that should be equal to -1. So it means that my green gradient, which is the line PQ, -1 on 3 multiplied by M is equal to -1. So m is therefore equal to -1 on -1 on 3, and this is equal to, if you reciprocate this and multiply it, you'll get 3 as the gradient of the line which is perpendicularly bisecting P and Q. So our gradient of the perpendicular bisector is 3 over here. Now from here we can go ahead and find our equation of the perpendicular bisector, now that we have the point 1, 4 and then the gradient 3. So let's go ahead and do that. So our gradient of the line will be equal to y minus y1 equals m into bracket x minus x1. Now our points that we saw in the previous over here, so we have -1 and 4, -1, 4, and then our gradient m, we saw that was 3. So let's do the substitution. We have y minus, our y1 is 4 over here equals the gradient 3 into bracket x minus -1 for our s over here. So I have y minus 4 equals 3 into bracket s plus 1. Y minus 4 is equal to 3 multiplied by s will give me 3s, plus 3 multiplied by 1 will give me 3. So y minus 4 minus 3s minus 3 is equal to 0. And then I have over here y minus 3s minus 4 minus 3 will give me -7 is equal to 0. So this becomes my equation of the perpendicular bisector, or I can rewrite this as y is equal to, I send -3s and -7 to the other side, it becomes 3s plus 7. So the equation here in gold becomes the equation of my perpendicular bisector, as we can see in this drawing that I have over here. Alright, so let's go ahead and have a look at another example. So we have to find the equation of the perpendicular bisector of the line joining the point A 2, 4 and then B 5, 3. Alright, so let's go ahead and write down our solution. So I'll try and draw the graph so that we can actually visualize what we are talking about. So I have over here 1, 2, 3, 4, 5, 6. This is my x-axis. This is my y-axis. So this is 1, 2, 3, 4, and let's see 5 over here. Alright, so my first point here is 2, 4, so it means my s is 2, then my y is 4, so it's somewhere here. And then my second point, so this is A 2, 4. My second point is B 5, 3, so I have 5 and 3, that is going to meet somewhere here. So this is B, which is 5 and 3. Alright, so I can now join these two lines, these 2 points, to have my straight line. Now this is a straight line, so because I'm using freehand sketch, it's not straight, but if you plot it in a graph you should get a straight line. Alright, so let me draw my perpendicular bisector. So that will be a line that is cutting through this point at an angle of 90, and then this distance over here from A to the midpoint and then from the midpoint to B are equal. Alright, so now that we have this, the first thing we need to do is to find the midpoint over here. So our midpoint MD is equal to S1 plus S2 on 2, Y1 plus Y2 on 2. So that will be equal to, my S1 is 2 here, plus my S2 is 5 on 2, then my Y1 is 4, plus my Y2 which is 3 on 2. So my midpoint is equal to 7 on 2, and then over here 7 on 2 as well. So that becomes my midpoint for these 2 points A and B. Now that I have the midpoint, I need to calculate the gradient of the line AB and use that to find the gradient of the perpendicular bisector. So to do that, my gradient of the line AB, M, is equal to y2 minus y1 on s2 minus x1, and that is equal to my y2 is 3 over here minus my y1 is 4 on s2 is 5 minus x1 is 2. So this is equal to 3 minus 4 will give me negative 1 on 5 minus 2 will give me 3. So 1 over 3, negative 1 over 3 becomes my gradient of the line AB. So to find the line of the perpendicular bisector, because they are perpendicular, it means M multiplied by the other M, which is the gradient of the perpendicular bisector, which is in gold over here, should be equal to negative 1. So the M over here will be equal to negative 1 on the white M, which is negative 1 on 3. So this is equal to negative 1. We remove the revision sign, it becomes multiplication, and then we reciprocate this, we get negative 3 on 1. So negative 1 multiplied by negative 3 will give us positive 3. So the gradient of our line perpendicular to the point A and B is 3. So now that we have the point 7 on 2, 7 on 2, and the gradient 3, let's go ahead and find the equation of the perpendicular bisector. So our points are 7 on 2, 7 on 2, and then our gradient M is equal to 3. Let's say our point is C. So the equation becomes y minus y1 equals M into bracket x minus x1. So I have here y minus y1 is 7 on 2 is equal to M, which is 3 into bracket s minus 7 on 2. Alright, so from here I multiply through by 2, so I have 2 multiplied by y minus 7 on 2 is equal to 2 multiplied by 3 into bracket s minus 7 on 2. So from there I have 2y minus, this will cancel this, so I have 7 here is equal to, this becomes 6 multiplied by s minus 7 on 2. So from here I proceed, I have 2y minus 7 is equal to 6 multiplied by x will give me 6x minus 6 multiplied by 7 on 2. 2 going to itself 1, it will go here 3 times. 3 multiplied by 7 will give us 21. So from here I can now go ahead and simplify my equation. So that will give me 2y minus 7, sorry, so I have 2y here is equal to 6s minus 21. Then I send the negative 7 to the other side, it becomes positive 7. So I have 2y is equal to 6s minus 21 plus 7 will give me minus 14. So I have this as my equation, or if I like I can divide both sides by 2. So I have y is equal to 3s minus 14 on 2 is 7. So this becomes my equation of the perpendicular bisector of the line cutting through the point A and B as shown over here. So thank you so much for watching. This is how we find the equation of the perpendicular bisector of any given line. So thank you once again for watching, and I will see you in the next video. Bye bye.